Okay. Now let's try modulo equations. Um, so in a sense, we're just going by like how we first learned multiplications in elementary school, right? Yeah, so what do? You first learn how to add, and then you learn how to multiply, and then you learn how to exponentiate numbers, and once you're confident with that, now you ask an inverse problem, like this times 4 times some number gave us 8. What is that some number? You ask a question like that, then you see that it should be 2 after dividing both sides by 4, right? So here's a similar kind of question. It's like there's a number whose triple, so there's some 3 times x, and in mod 5, this is going to give you 2. That's what the question is asking for. Okay. Now here's a dilemma though. You want to divide by 3, but dividing by 3 will give you 2/3, and that's not allowed in this system because ultimately we are only working with integers. Fractions don't exist here. Okay. Only natural numbers exist. So you're not allowed to do any computation that would yield a fraction. Okay? And therefore, instead of division, you want to multiply something both sides so that this left side turns into 1. Is there such a number? It's really hard to think if you haven't seen it. So the hint is this. What are the available numbers in mod 5? 0, 1, 2, 3, 4. That's it. In the mod 5 world, every integer is one of those 5 numbers. 0, 1, 2, 3, 4, 5. Right? Not 5. 5 is the same as 0. Okay? Do you agree? Yeah. So if I said, find the number where you can multiply both sides so that this left side turns into 1, it's basically a multiple choice of 5 choices. Would 0 work? If I multiply 0 both sides, would this turn into 1? Of course not. 0 times anything is 0, so you just get 0 equal to 0. Nothing comes out of that. Would 1 work? 1 doesn't change anything, so that doesn't work. Would 2 work?
Work for one side.
Huh?
Work for one side.
Yeah, multiply by 2. 2 times 3 is 6. 6 mod 5 is
1.
1, right? It does work. So what you do is you multiply both sides by 2. And then this becomes 6x. 2 times 2 is 4. But 6 mod 5 is 1, so that's same as x is congruent to 4 mod 5. Okay, so the answer is 4. 4 satisfies that property. Okay, let's check. What is triple of 4? 12. What's 12 mod 5?
2.
2. Indeed, that's true, right? Yeah. So 4 is the smallest number that will satisfy that. Okay. All right. So example 2. Let's try something bigger. Okay. Let's try 7x congruent to 5 mod 11. Okay, now we have a lot more numbers to play with, right? Mod 11, we have numbers from 0 through 10. Those are the numbers that are possible here. What numbers can you multiply both sides so that the left side turns into 1 times x? Can you think of what? Okay, there's something similar, but not exactly. So here's one you can do. If you do times 2 is 14, that doesn't work. That's congruent to 3. If you do times 3, what does that give you? You get 21, right? But yeah, which is 10. However, that's same as -1. Isn't that true? Yeah. So if you multiply by 3 both sides, oh, by the way, once you agree on one of the modulo system, you don't have to write it all the time. 3 times 7 is 21, but 21 is congruent to -1 mod 11, right? Because if you do 21 minus -1, that's 22, which is divisible by 11, right? So because 21 is equal to 21 minus 2 times 11. See, 11 in this world is same as 0. So subtracting 2 times 11 is the same thing as subtracting nothing. But if you actually do this, this is 21 minus 22, which is congruent to -1. Right? So these two are the same, which means that this can now be written as -x congruent to, well, 15 is, well, let's write down 15. Yeah. Okay. And now you can multiply by -1 both sides again. Okay? So multiply by -1 both sides, and the x is congruent to -15 mod 11. And -15 is congruent to what positive number? Well, you can reach the positive number by keep adding 11 until you hit the smallest positive number, right? What do you get? Keep adding 11 on -15 until you get a positive number.
22.
If you add 22 to -15, what do you get?
7.
7. Okay. Now, indeed, if you do 7 times 7, which is 49, what's 49 mod 11? Well, 44 is just less than 49. It's divisible by 11, right? So you end up with a remainder of 5. So it does satisfy this. This does satisfy this. Okay? Is that good? All right. Now, you might wonder, by the way, so putting these two together, we see that it's really -3 times 7 that gives you 1. Okay? -3 times 7 is -21, which is congruent to 1. But -3 mod 11 is, if you add 11 to this, that's 8, right? So we see that 8 times 7 is congruent to 1. Indeed, 8 times 7 is 56. 56 mod 11 is 1, because 55 is divisible by 11, right? So if such a thing happens, so we could have solved this by just multiplying by 8 both sides, okay? And if such a thing happens, then you say that 8 is the multiplicative inverse of 7. That's the way we say it, okay? Now, we were trained to think of 7 -1 as 1 over 7, right? But that's in the regular real numbers, okay? This -1 is the inverse of 7 under the modulo multiplication. So this -1 and this -1 has different meaning, okay? So when we say -1 here, it really means not this one, but the number that causes it to give you 1. That's what it means, okay? Now, the next question that you might have is like, if I throw in any number here, do you always have a solution, right? That's the question. And the answer is, first of all, if this number is a prime number, and this is non-zero, it's not congruent to 0, then you always have a solution. And the reason for that is the Fermat's little theorem. See, we know that 7 to what power mod 11 gives you 1? What should this be? Well, we can just calculate phi of 11, right? Which is prime itself, so it's 11 to the first power, so that's what? 11 to the first power minus 11 to the 0th power, which is 11 minus 1, which is 10, right? Is that right? Okay. So what that means is that if we do 7 to the 10th power, that's going to be 1 mod 11. Right? Which means that if we do 7 times 7 to the 9th power, that will give you 1. So as long as you have a prime, because of the Fermat's theorem, you can always come up with such a number. 7 times 7 to the 9th power is 1. And indeed, if you calculated 7 to the 9th power mod 11, guess what number you're going to get if you reduce the smallest number? If you computed this, you're going to get, no, 8. Because that's what it is. 8 times 7 is 1, right? Yeah. So this is not, this number, 8 times 7 is going to give you 1. So this number will be 8. 7 to the 10th power would be 1, but 7 to 9th power would be 8. Mm-hmm. Yeah, you can actually try computing and you'll see that. Okay. So that's how you do it.